In this video, we will talk about the distance formula. First of all, in a coordinate plane, I'll draw a coordinate plane here. X-axis, Y-axis, and we have 2 points on the coordinate plane. First point, let's call it P1, and second point, P2. Let's assign an ordered pair to P1. Let's call it x1, y1. And the coordinate plane for the second point would be x2, y2. Oops. Okay. Well, the distance formula tells us the distance between P1 and P2. So basically, how long the segment P1, P2 is. Well, let's use some knowledge we know to find the distance between P1 and P2. So first of all, what is this value on the x-axis? Well, this value should be x1 because that corresponds to the x-coordinate for P1. And similarly, this value here on the x-axis is x2, which is the x-coordinate for P2. Okay, so how long is this segment? In other words, how long is this? Well, you can tell this segment is this part, x2, minus this part, x1, which is, that's right, x2 minus x1. That's how long that segment is. How long that segment is. Okay, so now let me use a different color. Similarly for the y-coordinates, this will be y1 and this will be y2. That doesn't right. y2, and the length of this segment, or let's say the length of this segment, would be y2 minus y1. Okay, so notice that this is a right triangle. Right triangle here. And the distance between P1 and P2, that's what we're looking for. This is the hypotenuse of the right triangle. And y2 minus y1 is one leg, and x2 minus x1 is the other leg. And we know there's a famous formula in a right triangle. It's called Pythagorean theorem, which talks about c squared equals a squared plus b squared, where c is the hypotenuse and a and b are the legs of the triangle. Okay, so similarly here, the distance between P1 and P2 here, let's call it d. Since d here is the hypotenuse of the triangle, so d squared should equal to the sum of the two legs squared, right? So the first leg, let's use this leg as our first leg, which is x2 minus x1. So first leg squared will be x2 minus x1 squared. Okay, So plus the second leg, which is y2 minus y1, second leg squared. Well, this is not the distance formula. This is the distance squared formula. So to find the distance, or to leave d by itself here, we need to square root on both sides. So in this case, d equals square root of, well, since distance is always positive, we don't use the negative value. Well, square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so here, this is, I wanted to use the highlighter. This is the distance formula. Okay, now an example. Right, say we have 2 points on the coordinate plane. One is 3, 5, and the other is -2, 7, for example. And I want to find the distance between these 2 points. Okay, I'm going to use the distance formula, which is the distance equals square root of, well, here we have to use x1, y1, x2, y2. How do we know which one is x1, which one is x2? Well, let's assign them. You can assign either one as x1, y1. I will use the first point. This is x1, this is y1. As long as they're, x, y, x, y. And the second point, x2, y2. Oh, there. Okay, so plug in the numbers. Well, square root of x2, which is -2, minus x1, 3, squared, plus parentheses y2, which is 7, minus y1, 5, squared. Well, let's do the calculation. Square root of, so first is -5 squared, which is 25, plus 2 squared, 4. 25 plus 4, 29. So the answer is square root of 29. That means the distance between the 2 points 3, 5 and -7 on the coordinate plane is square root of 29. And since 29 is a prime number, we can't simplify this square root of 29, and we'll just leave that as our answer.